Welcome to our workshop on transformations. I'm assuming that you've seen this topic, and we're going to go through just some hints, a few questions, looking at just, we'll dive in at a few different points. It's by no means comprehensive, but it's a workshop. So let's grab a pen and away we go. There's three basic questions that you'll encounter. There's the ones where you're given like an original point and asked to find the image point. The image point, we refer to it as x prime, y prime, the point on the transformed curve, coming from the original point, x, y, or I guess you could be asked to go back the other way. So it's about points, and really what happens to individual points or general points does underlie this whole transformations topic. So if you're given a point on an original function, you want to find its image point on the transformed function, you might be given the transformation steps, like you might be told that it was dilated by a factor of half away from the y-axis, or it might have been translated 2 units left or something like that. So you might be given that information, or you might be given both of the functions, the original and the transformed function. So we'll have a look at some examples of there. Number 2, if you're given the equation or the graph of the original, you've got to find the equation or the graph of the transformed function. Maybe you're given the steps, that's the usual thing, or possibly some original points and image points, a bit of a graph situation. So this is a next one is about going in between the original function and the transformed function, or vice versa, given enough information to go between them. And there is a connection between points, what happens to points and what happens to functions, of course. And the third thing is, given the original and the transformed functions, show what the transformation steps are. So, was it dilated by a factor of 3 from the x-axis, or was it moved down 4, or whatever happened? So you need to write down what were the actual steps that made the original become the transformed function. And just a few key ideas, just bear this in mind. If you get x prime or y prime as the subject of equations, like x prime might be equal to x plus 4, and y prime might be equal to 2y minus 1, right? Something like that. If x prime and y prime are the subjects, then you can straight away, you can figure out what transformation steps have happened. And you can also figure out the coordinates of all the different image points. So it's a great idea to have x prime and y prime as the subject if you're asked to move a whole lot of points from an original graph to where they would be on a transformed graph. Second dot point, if x and y are not x prime and y prime, but if x and y are the subject of the equations, then we can determine the equation of the transformed function. So sometimes we need to rearrange and make x and y the subject, but once we've got that set up, we can do that. And the third dot point kind of relates. Given the equation of a transformed function, we often have to rearrange to get the function bit only, like f of something only by itself on the right hand side. Sometimes you might have 3 times some function of x plus 2. You need to get rid of the 3 and the 2. Just have the function on the right hand side, because you want your original equation function and your image one, your transformed one, to be of the same format. We've often done this sort of thing when we worked with linear functions. We try and make things look like y equals mx plus b. We rearrange, get it in a certain format, and then we can, read off the y-intercept or the gradient or whatever. Well, in this case, we do the same thing. We try and make them in a format that we can just directly make comparisons and work ahead. So that's just some key ideas, and I'll keep referring to those as we look at some examples. So I'm saying these examples here are examples where we're moving between image points and original points, vice versa. So the first one is they've got this graph and they're telling you what happened from going from the original to the transformed. They're telling you that it was dilated by a factor of 1/3 from the y-axis. It was reflected in the y-axis, and then it was shifted 2 units in the positive x direction. So after all that, they want to know, well, what happened to an original point, 9 minus 2? Where did it end up under those transformations? So if I just write down here, I've got this original point on the original curve, xy. That's always a good starting step. And I'm going to go through bit by bit and write down what happened. Well, the graph was dilated by a factor of 1/3 away from the y-axis. If you're moving away from the y-axis, you're moving horizontally. So it was actually the x that was affected there. So I'll write 1/3 x. It was reflected in the y-axis. So the next thing that happened, if you reflect in the y-axis, then x's become minus x's. So now we've got minus 1/3 x happening. And finally, it was shifted 2 units in the positive x direction. So we have minus 1/3 of x, and we moved 2 units in the positive x direction. So nothing happened vertically there in that whole situation. So that means that the image point will have the same y value as the original. So I'm just going to write down that the image point x prime is there, y prime, right? The point above x prime, y prime is the same point, which means that x prime is minus 1/3 of x plus 2, and y prime is just y. Like I said, nothing happened in the vertical direction, so y prime is just y. I mean, in terms of multiple choice tactics, I'd be saying, well, this one looks good, this one looks good, neither of these can be it. The next thing I need to do is just go, well, let's take x, which in the original curve was, in the original point was 9, and let's pop it in there. So we're going to pop a 9 in there. What's minus 1/3 times 9? Minus 3. Plus 2? Minus 1. So D is the correct answer, because x prime, when you put that original x value in, x prime is minus 1. So our answer is minus 1 comma minus 2. The next question, the graph of function f passes through the point -2,7, then the graph of some transformed function is going to pass through which point? So in a way, they're saying, what's the image point of the point -2,7 under that transformation? Let's figure out what the transformation in fact is. So we've got some function y equals f of x, and they don't tell us what it is. They just say it's function f, right? And it became y minus 5 equals f of x on 2. Now, this is what I was saying on the page before. We want to have things written in the same format, kind of like the y equals mx plus b is a type of format that we restructure lines in so we can read off what's happening. I want just a function of x on the right-hand side, and that's why I've written f of x over 2 by itself on the right-hand side, because the original function is just y equals f of x. I don't mind what goes on the left-hand side. Sometimes there's a bit happening there. In this case, it's y minus 5, but sometimes it's also divided by something. That's fine by me. But I can see what's happened now. I can see what's happened point-wise in going from the original to the transformed function. Now, the image point lies on the transformed function. Any image point of a point that was on the original must lie on the transformed. So x prime y prime is a point on the transformed function. Therefore, I can change what I've written here and put primes there if I want, right? X prime y prime does satisfy that equation, so I can put them in there. All right, so what I'm saying is when I look on the right-hand side of the equal signs, they're set up in the same format. So I can say that the x is equal to the x prime on 2. And on the left-hand side of the equal sign, I can say that the y is equal to the y prime minus 5, because they're set up just to read them off. Okay, now, I said on the previous page that if you have x and y as the subject, well, you're looking at writing things in terms of the original function or the transformed function. You're able to determine things about the function. But if you want to determine things about the points, which are totally related, but you want to write x prime and y prime as the subject. So I'm just going to do that now. I'm rearranging. So x prime is 2x. And y prime is y plus 5. Now, what I've determined there by getting x prime and y prime, like I said in my notes at the beginning, we know about the transformations that have happened to the original point to turn it into the transformed point. That's what the x prime, y prime is, the transformed point as such, the image point. In other words, I'm saying that this point xy turned into 2x and y plus 5. Well, that means you give me any point on the original and I will double it to get, double the x value to get the image x value, and I will add 5 on to the y value to get the image y value. All right, the point they gave me was -2,7. So if I'm given -2,7 on the original graph, then it's got to be 2 times -2, so -4, and 7 plus 5, 12, right? -4, 12 is the image point. So that's C here, -4, 12. Okay, this next one here, they've given us an original graph and they've given us the original equation, y equals function of x, and the transformed equation, y equals -f of x minus 1. And they're asking us to now do another sketch. Now, if I can sketch a few points on the image graph and then join them up, that'll be a nice way to get my sketch working. A few key points, like this point here that was at the origin, where does that end up? This point here, where does that end up? The point out there at -3. The point on the top of this crest here, maybe there-ish. Where does that end up? And, you know, you could pick another point, say there. Where does that end up? And maybe that's enough points to give you an idea of how to get a nice sketch going of what's going on. All right, so first of all, I've got y equals f of x as my original function, and minus y equals f of x minus 1 as my transformed. Now, notice how I did that little trick there, right? I got rid of the minus from the right-hand side because it's in a different format otherwise. Look at the original, it's just got f of x on the right, and then look at the transform, it's got minus function or something. Well, I don't want them to be in different formats. So I divide both sides by -1, and then my right-hand sides are in the same format. Yep, it doesn't worry me what goes on the left. In this case, it's just -y. So I'm then able to say, I know that this is the transformed curve, -y is f of x minus 1. And with transformed curve, the image points lie on that transformed curve. So x prime, y prime lies on that curve. So I can just pop x prime, y prime in that equation and it will satisfy it. All right, now matching up the left and the right sides, the y's and the x's, I can come out with some equations relating together the original and the transformed. I'll write it down. I can relate that on the right-hand side here, x has become x prime minus 1, and y has become minus y prime on the left. Now, I want to know about the image points, where they're going to end up, because I've been given an original graph and I want to get each of the points that I've highlighted there and turn them to an image point. So I need x prime and y prime to be the subjects of the equation. So I just rearrange and get x prime equals x plus 1 and y prime equals minus y. All right. In other words, we've taken some point x, y, and we've turned it into x plus 1 and minus y, because that's the point x prime, y prime, the image point. So any point from the original, I plus 1 onto it to get where it ends up horizontally, where the x value has become, and I make it negative y. In other words, I flip it in the x-axis to figure out what happens to the y value of it. So I'll get another color out here to do this with, maybe orange. There we go. So this minus 3 point, it moves along to the minus 2. So this minus 3 point moves along to the minus 2 because it moves, it's like x gets plus 1 onto it. But then it flips, but it's already on the origin, so it's, flipping is the same place. So it just stays there. Now that's going to happen with this point that's at the origin. It's going to move along one place to be at 1 there, but flipping won't do anything to it. So they're the ones where it's cut through the x-axis done. This point here, it moves along one position to be there, but it flips now because it's y has become minus y. So it goes down to there. So what used to be the left-hand side of the y-axis now becomes this piece here, roughly. All right, now the next thing I need to do, now if I really wanted to be accurate and see where it cut through the y-axis there, I would have had to move 1 unit across and see there, it's just about 1.8 or something like that. So it really needs to go through 1.8 there. So I was a little bit far down when I went through there. All right. So, you know, if I wanted to be accurate, I would make sure that I went at about there, I went through. So I'll just, it's a little bit hard with this pen. That's not meant to be a line, it's a curve. Oh, and then I've gone and messed up through there anyway. But okay, so you get, anyway, it's, if you're in an exam, you'd have a pencil and you'd be able to work a bit better than with this. Now, the other point that I wanted to do was this one here. Now, it's going to be a bit hard to move this one unit to the right and then flip it, because it'll be out of the picture and it'll be, you know, it'll be up at there somewhere. I can't be totally accurate on that. So I might just come back and look at this point here, which is in line with the x equals 2. And what I might do is I might add 1 onto that, so it comes out to here, all right? And then flip it so it ends up here. And that just gives me an idea where that is at the end of there. So that went through there, and what goes up to here like that. And that would be my sketch. By just plotting a few key points using that point method, getting x prime and y prime as the subject. Given the graph of the function y equals fx below with turning points as shown, sketch the transformed function. Don't worry about the intercepts. So what I'm going to do, just get my blue pen back. I want to know what happens to each point. So first of all, I've been given y equals f of x. I want to set up the transformed function in the same format. So that'll be y plus 4 divided by 3 equals f of x plus 2. Now we've got just a plain function on either side. Don't mind that there's a bit of stuff going on the left. And I know that the image point of xy, that is x prime y prime, lies on my transformed curve. So I can substitute that in there and it will satisfy that equation. Now, because they're in the same format, I can say x on the right there, x has become x prime plus 2, and y is equal to y prime plus 4 on 3. And then I'm able to make x prime and y prime the subject, because I'm wanting to work with some points here. I want to move some of these points around, see where their images end up. So x prime is equal to x minus 2, and y prime is equal to 3y minus 4. So what I've just found is that an original point goes to the point x minus 2, 3y minus 4, because that's what my x prime, y prime point is. So I can now I've got a general formula for what happened to the different points. I can select some key points and make that happen to it. For example, the point minus 4, 7, it's going to go to, now you've got minus 4 minus 2, so minus 6, and 3 times minus 7 is minus 21, minus 4 is minus 25. So I just stuck minus 4 in for x and minus 7 in for y, and I get negative 6, which is, somewhere out here, down at negative 25. So I'm probably not going to be able to do the best sketch of it, but let's just give a vague idea here with the room that I've been given. The point 0.06, if I follow that pattern there, I end up at the point minus 2, 3 6s are 18, minus 4 is 14, all right, minus 2, 14. So minus 2, 14 is somewhere up here. And I'm going to have to do a second video here for the rest of this worksheet. So hang in there and I'll give you the other link for that wherever I give it. But I hope this has helped so far on this first half of this workshop.